Yes, friends. So we are taking now permutations and combinations, or combinations and permutations, right? Now this topic is important so far as probability is concerned, and other things are also concerned. Whenever combination permutations are used, and for those topics I'll discuss about them later. But now I've just described it. What is the combination? What is a permutation? Now combination and permutations are the two types of arrangements of or selection or arrangement, or what is that let me clarify. Okay, and after that we will take these questions which are very important to illustrate this topic, okay, in vividly or in a very vivid manner, or in an illustrative manner, in a very large manner, okay, in broad manner. Okay, so just to explain this topic broadly, I have taken these questions, and I wanted to take some formulae also which are very important just to utilize. There are certain basic facts based on combinations and permutations, okay, that I'll take in the next lecture series. But before that, let me first start that what is combination and permutation, because this topic is as important as other topics, very important topics. So this is one of the important topics I have taken here, because before doing probability, because combination and permutation, mostly combinations are used. In case of combination, formula is used in case of probability. Okay, so finding the probability of certain things. Okay, selection of suppose some things are selected out of some things, and that case of selection we will use the formula of combination. So because of that, I have to describe it. What is combination? What is permutation? Okay, now let me take this. Okay, and then these questions are to be solved. Okay, so let me take one by one, and then questions which are, because I have taken here the first question, the very first question says, what is the difference between combination and permutation? First let me describe that, what is combination, what is permutation. After that I'll talk about the difference. Okay. First is, I've taken here combination and permutation. So if I talk about combination first, no problem, let me take combination. Okay, so combination. What is combination? Let me first describe this. Combination is, okay, if, let me take out of n items, or n, let me take out of n things, or out of given things, out of n given things, right? Out of n things, some or are selected out of n objects, out of n things or objects, okay, without or irrespective of, this is known as irrespective of order. Now here order doesn't matter, right? If order is to be mentioned, then we will talk about in case of permutation. Okay? Permutation is with order, because order if it is mentioned, then permutation is done. In case of combination, order is not there. I mean, irrespective of order, then the selection is known as, then the selection, let me take, then the selection or grouping is known as combination. I'll take an illustration for both of the things when I define them. I mean, when I differentiate them, combination, permutation, then I'll take the illustration or one illustrative example. Okay, and that example, that illustrative, will give us how the difference is there. Okay, so it's known as combination of things, or grouping of things, or selection of things. This is known as, okay, the formula. Okay, if, let me take one illustration. What the formula of use this? If out of n objects, let me take, if out of, if out of n objects R are selected, take R are selected, R are selected at a time, okay, at a time, then the combination of R objects out of n objects is given by the formula. I'm writing here the formula. Is given by the formula. I'll just illustrate that, okay, with with clear way of how the point is clear, or how this formula is used, what this formula means that I'll talk about. By the given formula, and is written as NCR. NC, this C denotes combination. This C, capital C here, denotes combination. So out of n, R are selected. So this formula is given by, this is factorial. Sign of factorial is either this or this. I'll just talk about that. Okay, upon factorial R, this R, into, in under bracket, difference of the two items, n minus r factorial of that. What is factorial? What is this? That I'll define that, how this formula is, and what is the value of this. Okay, I'll take one illustrative example. Alright. If, let me take, if out of 4 questions, take out of 4 questions, 1, 2, 3, and 4. Right, here the value of n equal to 4. Here, if out of 4 questions, 1, 2, 3, right, 3 are selected. Let me take this above. If out of 4 questions, 3 are selected, then out of 4 questions, 1, 2, 3, 4, 3 are to be selected, 3 are to be selected or done, 3 are to be selected by the students, then the base of selection, 4 different questions are to be done by them. Okay, 4 questions irrespective of order, right? Order is not there. Only 3 questions are to be done out of these 4. What is the way of that? Then the 3 questions, the students, then the base of selection, the base of selection of questions. Selection of questions will be, what are those questions? Either 1, 2, 3, 1, 2, 3. These 3 questions can be selected, or 1, 3. This is 1, 2, 3. Then 2, 3, 1. Let me take 2, 3, 1. This is another way. 1, 2, 3. Right? 2, 3, 1. Then, because this 4 is also there, let me take 1, 2, 3 I have taken here. And if I take 1, 2, 4 is also possibility. 1, 2, 4 out of these 3 questions, right? 1, 2, 3, 1, 2, 4, and then 3, 4, 1 or 3, 4, 2. There are the 4 way of selection. Different questions are to be selected. Okay, this is the unique questions are there. Okay, 3, 4, 2, 3, 4, 1. This is the 4 questions are to be selected irrespective of order. Order is not mentioned, and there are 3 different four different possibilities, right? Of selection of 3 questions out of these 4 questions. 1, 2, 3, 1, 2, 4, right? And 3, 4, 1. Now in this case, we are seeing that the 3 is coming 3 times. 1, 2, 3. 1 is also coming 3 times. 1, 2, 3. 3 is also coming. Okay. 2 is also coming 3 times. 1, 2, 3. 4 is also coming 3 times. 1, 2, 3. These are the 4 unique ways, right? Now out of this 4, only 3 questions are to be selected. These are the unique way, irrespective of order. Now these are 4 different ways. So how this question is given, this formula is applied. So these are the 4 ways. Answer is 4 here are to be selected by the student. Then the ways of selection of questions. Okay, there are the unique questions here, irrespective of order. This is irrespective of order. Now what is the formula here? This is 4C3. The formula is factorial 4 in the numerator. But the value of factorial 4 are double and upon factorial 3, the difference of these two, 4 minus 3 factorial. So this value is factorial 4 means 4 into 3 into 2 into 1. You multiply factorial 4, factorial. And to talk about factorial, this is factorial. Factorial. And denoted as either this, like exclamatory sign, or like this, like it is not an angle but straight line. And this is straight line. This is factorial n, factorial n, factorial n, either this or this. These are 2 symbols, either this exclamatory sign or this. Okay, that's angle type. Okay, so that is the one way. So I'm taking this exclamatory sign, shaping of exclamatory sign. This factorial n upon formula is factorial n upon factorial r into difference in the denominator, difference of the 2 n minus r, factorial of that, factorial of n minus r. This is the formula which here are to apply. What is the factorial 4 means? 4 into, let me take 3 into 2 into 1. This is factorial 4 means. Factorial 3 means 3 into 2 into 1 into, this is 4 minus 1, 1. 1 factorial is only 1. 1 factorial means 1 only. So what is this? These 3 to 1 cancelled out, only 4 is left. See here, there is a 4 way of selection of 4 questions in a unique way. So only there are 4 different ways of solving those questions. Out of those 4 questions, these are the 4 unique ways of selection, right? This is how combination is there, the unique way of selection. But if I take irrespective of order, let me take what is irrespective of order. It's the same question. If I take that out of these 4 questions, only 3 are selected, no problem. But irrespective of order, then what the combination is 1, 2, 3 can be combined. Now in case of permutation, let me take. And what is permutation? Let me take permutation. Permutation means if out of n objects, let me take n objects here or n things. If out of n objects, some or all are taken, selected, or are arranged, are selected or arranged, then the different kind of arrangements, then the different arrangements are known as permutations. These are different arrangements. In this case, with order, respective of order, not irrespective of order, but irrespective of order. Okay, with order, we may say, with selection of order. Let me take here with respective of order, with respective, with respective of order. Here order is very important. Irrespective of order, with respect of order, respective of order, or with respect to order. Right? In this case, order is very important. In case of arrangements, these are different kinds of arrangements. In case of permutations, we say there are different kinds of permutations, arrangements. So arrangements is proper word for permutation. Permutation is arrangements. And here in this combination is selection. Selection, combination. Both same things, similar things. Now here in this case permutations, arrangements. Now different kind of arrangement. Now suppose if I take this one here, okay. Then what is the formula for this? This permutation, let me describe here. Now if I take in case of permutation, let me define this further. That in case of this one example here. Now if order is important, if order is important, then the possible arrangements or possibilities, possible arrangements of the above three questions, of the above three questions, out of four questions. Now here are the four unique way of selection, right? These are selections, four ways. Now this every or unique way can be selected in how many ways? Suppose this 1, 2, 3. Let me take this 1, 2, 3, one way of selection out of this n ways. There are different kind of other, ways. Let me take this. This can be selected in how many ways? Now out of these four questions, let me take in. If order is important, then the possible arrangements of the above three questions out of four questions will be. Let me write here. Now suppose this 1, 2, 3 is to be arranged, then 1, 2, 3, right? This is 1, 3, 2, two possibilities, then 2, 3, 1, 2, 1, 3, 3, 2, 1, 3, 1, 2. How many possibilities are there? Here the irrespective of order. Irrespective of order. Now here we are taking 1, 2, 3, 1, 3, 2. Just reversing these two. Then again 2, 3, 1, 2, 1, 3, 3, 2, 1, 3, 1, 2. These are 6 possibilities of just one unique arrangement. Okay, this one selection 1, 2, 3 can be arranged in 6 ways. Similarly, these 3 others, this way can also be arranged in 6 ways. This can also be arranged in 6 ways. This can also be arranged in 6 ways. So total arrangements can be done in how many ways? 4 into 6, 24 ways. Right? Similarly, 1, 2, 4, 3, 4, 1 and 3, 4, 2. Okay. Select these selections, these combinations can be arranged in 6 ways each. In 6 ways each or every one. What does it mean? It means this 4 into 6, there are 24 ways of selection of these. Now respective of order in this case. So total ways of arrangements, hence total base of arrangements or permutations, or permutations will be this 4 into 6, that means 24. Right, total arrangements in this case is 24. What is the formula here? Formula for NPR, for permutation. Hence, this arrangement or permutation can be given by a formula as, what is the formula here? NPR. Here NPR, but N is here 4, P permutation, P for permutation, and a total number of cases. Out of that, R means 3. And this formula is N for P3 is equal to factorial 4 upon difference of these two, 4 minus 3 factorial. This is factorial 4 upon factorial 4 minus 3 in the denominator. But the concept now in the denominator we are having 4 minus 3 means 1 factorial 1 is 1. So this is factorial 4. Now factorial 4 means 4 into 3 into 2 into 1. Let me take that here. Therefore, hence NPR of 4P3 is equal to factorial 4 upon factorial 1 is equal to factorial 4. Factorial 1 is 1. Factorial 4 means 4 into 3 into 2 into 1. 4 3 are 12, 12 to 24. Total 24 arrangements are there. So this is how the formula is fit. Now this NPR formula or permutation formula is giving us 24 here. 4P3. So arrangement of questions irrespective of order. I mean, when order is mentioned, order is important. In which order the questions are to be done. That order if it mentioned, then permutation is there. Arrangement, total arrangement, in any way arrangement can be done. Okay, order is very important in this case. So irrespective of order, when order is important, that way different cases of arrangement, different possibilities of arrangements are 24. That as I have just explained this question here. Okay, out of those 4 questions, here the 4 unique ways of selection of 3 questions out of 4. Which one? 1, 2, 3, 1, 2, 4, 3, 4, 1, 3, 4, 2. Only these 4 different or unique way of selection of 3 questions out of 4 is there. The 4 combinations. Combination is irrespective of order. Order is not mentioned here. Order is not important. There is only unique ways, and unique way means that kind of arrangement is not another one. Now this 3, 4, 2, this is 3, 4, 1. Different arrangement. All the 3, 4 are unique. All these 4 are unique arrangements. Unique means selection. Selection or combination is unique. They are not repeated. Okay, so irrespective of order. Now in this case, when order is there, order means repetition may be there. I mean, 3 questions are coming again and again, but they are arranged in different ways. Arrangement is there. Arrangement is, order is important. So this is 24 how we have taken. The formula for combination and permutation, they are important. What is the difference between combination and permutation? In case of combination, irrespective of what unique way of selection is there. We have to select the 3 items. For example, out of 4 students, only a team is made of 3 students. There is only one unique way. What is the unique way? Either this person can be selected out of those 4. There are these 4 type of unique way. One student, 2 second student, third student. 1 first student, second student, fourth student. This is another combination. unique combination. In this case, the 3 is not repeated here. Or this can be other possibility: 3, 4, 1. Third student, fourth student, first student. A team is made of 3 out of these 4. Okay, so 3, 4, 2. This is unique way. So these are the 4 unique possibilities. Selection of students of a team of 3 students out of 4. This is the unique way. So selection is, combination is selection, unique selection. Order is not important. Okay, in that case, unique way is there. So irrespective of order. But in this case, in case of combination, 24 possibilities are there. This one can be selected in 6 ways. This can also be selected in 6 ways. 6 ways. 6 plus 6, 4 times. So 6 plus 6, 4 times. That means 6 into 4, 24. So permutation is arrangement. Now in this case, order is important, right? So irrespective of order, combination, irrespective of order is permutation. In case of permutation, arrangement is there. Arrangement can be done. Okay, 3 questions can be selected in different arrangements. Like this 1, 2, 3 we are selected in 6 ways. Okay, 3 questions are not unique here, they are repeated, but they can be arranged in the order. What is the order here? 1, 2, 3, or 1, 3, 2, maybe order 2, 3, 1, first, second, then third one, then last third one is 1, the first one. So I mean, in that way, order is important. So which order is there? If order is important, then permutation. Arrangement is permutations. Permutation is arrangement. And combination, unique combinations. Combinations are unique. So, okay, so this is the only difference between the formula which I have just told you about. Factorial, what is, let me take, what is the factorial? Factorial. Factorial is denoted symbol for them. Symbol for factorial is this, either this symbol or angle type of symbol, but this is straight. So if I take factorial and first write n, then sign of factorial, symbol of factorial n, this is denoted as factorial n, and this is also known as factorial n. So either this symbol or this symbol, so either of the 2 symbols can be used to denote factorial. Okay, so the formula for combination permutations are important, and upon this there are certain other formulae which are important here. Now let me further explain that over this combination permutation there are different other kind of possibilities. Okay, very important formulae are there, or important results you may say. There are important results based on combination permutations. Let me describe them. Let me talk about them also. What are those important possibilities? There are 3 important formulae which will be used here also to solve these questions. Let me talk about those 3 important possibilities. What is the formula for? There is a relationship between combination and permutation also. What is that? Let me just talk about that. If I describe the combination, or what is the the formulae of combination permutation, they are related to each other. How? First, we know that NPR, this is capital NPR, N total number of items, P denotes permutation, and R out of N, R are selected, R are chosen, R items are chosen out of N items. That can give us, what that can give us? The formula is factorial n divided by factorial n minus r. Okay, this is first equation that we take, and as I have told you, NCR, combination formula, out of n, if r are selected out of n, then this formula is factorial n upon factorial r into factorial n minus r. What does it mean? Now if I take this factorial r to this side, then factorial r multiplied NCR